Assalamualaikum. Today I will present about my simply supported beam. First, we need to find the area distribution. I get from find the height of this thing, and then times with the area, and then to total of this thing minus 12 this, and then divide by 2. I get this formula. Then for this, I find the height of this thing, 1 point tangent 30, and then times with the area, I get 1.63 meter. Xenom get 25 millimeter. Ding I get 6 millimeter. Bar I get 12 millimeter. Effective depth get I assume H cylinder span over 10. Then I get 3 to 3.4 millimeter. BW 250 millimeter because continuous beam is 250 millimeter. Effective depth minus I get 286.4. Slab thickness 123.75. I get it because my slab is 123.75 millimeter. For load analysis, first we need to find the density and then times with the slab thickness and the area. Area divide by length. Same for this, I get to 198 and 1.5. Brick wall, I get the density in kg, and then I times with the height of the brick wall. I get 9.351 kilometer per meter. Finishes 1 divide by area, I get 0.2478. Faster I get 1.603, and then add up I get 15.682 for GK. QK get 1.445, 0.683. Total up 2.128. For W I use 1.35 and 1.5. Times with the GK and QK, I get 2.34.367 km per meter. Then for moment, the formula is WL squared over 8. I get 34.34 km. For K, I get 0.0558, lesser than 0.167. And then I find Z, but my Z is over 0.95D, so I use 0.95D. AS required, I get 290.14. So from the table I use 4H10 T14. For AS minimum 150.475. 286. For AS max I get 2864. For my AS required plus the AS requirement. Then we go to crack check. I get 44 millimeter for S, and then AFS I get 500. So I get this, and then from the table I get 100 millimeter. And then design issue force, WL over 2, I get 1.81 kilonewton. Then find VRDC, I get 37.265 kilonewton. Then my VD is bigger than VRDC, so I find VRDC max, I get 235.95. Then I find ESW, and then I select 300mm for stirrup. Then for deflection, as required over VD, get 4.052 times 10 negative 3. Row node, I get 5.84 times 10 negative 3, and then L over D, I get 35.6365. For modification factor, I get 1.36. So my L over D allowable is bigger than my L over D actual. Then for the detailing, I get this. Then BQ, first I calculate the concrete. I get 0.31 square of concrete, and then reinforcement, I get 6 meter. First length minus cover, at bend, then that I get 6 meter. Then for stirrup, I get length minus cover, I get 0.2732. Then the height minus the BW minus cover, I get 0.2. I plus with length body, and then I get 0.4732. Then we need to find the number of stirrup, the total length over the diameter and the spacing. I get 12.19. So I go for 13. Then 13 times the 0.95, the total, and then I get 12.35 meter. Then for formwork, I get 1.05 millimeter squared, the length times the y direction, and this the length times height, this the length times height, get 0.923 meter squared, and then this one the length times the width, I get 0.4 meter squared. Sound tiba. For the BQ, get 12 RM 128.94. Then for my continuous beam, get for beam D7A to 1, first we need to find the preliminary beam given BW 250mm, H 550mm, FCK 30, FYK 500, SPJ class SC1, design class S4, effective depth, I get 513mm. Then for slab distribution area calculation, same for simply supported. Find the area of triangle, and then I minus whole of this thing, I minus two of this and divide by 2 because we got same for my span 6 to 5. This one is for secondary beam, this one for the left side, so I get 1.7703 for area for the main beam, and secondary beam I get 2.738 and then for span 5 to 454 find the area of this triangle minus with whole of this, then divide by 2, I get 1.0583. Then this thing I get it has 2 rectangle, so I divide by 2 times the area, and then I get 1.3935 meter square. For span 4 to 1, same thing, this thing I find the height of this thing and then times with the area of triangle, then this divide by 2, I get 2.323 meter square. For load analysis, slab thickness 123.75 because I get my slab is 123.75 millimeter. To span 7A to 6, I calculate the slab, brick wall, finishes, plaster, and total up the W. For span, this one is for secondary beam, so I convert it to point load, then I get 36.0236 kilonewton. Then for span 6 to 5, I get 20.3586 kilonewton per meter. For span 6 to this one is span 4 to 1, get 21.7125 kilonewton per meter from this. Then moment distribution for 7A to 6, A is 1.3 meter, B is 3.656 meter. Then I find the point load for 29.28, 14.655 UDL, I get plus minus 90.2477. Then I total up point load and UDL, I get negative 119.63 for 7A, 105.003 for 6M6. Then for the span 65 to 454, the for M6 and M5 I get 5.682, M5 to and M4 I get 5 points. This one is negative, this one positive. From 4 to 1 I get negative 1 as 16.81, and M1 I get 16.81. So after that we need to find the distribution factor. The E I use is 27386.13 Newton per millimeter square. I BW squared BW times H squared over 12, I get 3.466 times 10 to power of 9. So find the K, and then find the diffusion factor. I get 0, 0.75, 0.25, 0.5, 0.375, 0.625, 0. So my moment distribution method, I get negative 157.843 for 7A, 627A to 8.58323, 625, negative 28.58, 524, negative 1.9715, 425, 1.9723, 524, 11.466, 69, 421, negative 11.469, 124, 19.4805. Then I find the direction force. First, I find the R6A. I get 58.81. RC7 117.90 kilonewton. For span 6 to 5, R5A I get 35.32. R6B I get 1.936. For span 4, 5 to 4, for A I get 11.284, and then R5B I get 25.97 kilonewton. From 4 to 1 I get 30.468 kilonewton, and then for the R4B I get 4.67 kilonewton. This is my shear force diagram, and then my bending moment diagram. This one is negative area and this positive, so then we need to find the main reinforcement. For the main reinforcement, I use the highest value moment, then I get 277.41. I use 3H10, 3.4 bottom. Then for support, I use the highest 157.843 moment. And then yes, required I get 768.83, so I put it at top. For design shear force, use VD 117.93, the highest. So I find VRDC. My VRDC is bigger than VD, so I calculate the Vmin. Then ASW, I get H12 200 center to center. Deflection, though equal to ES squared over BD, get 2.16. The L over D 53.57, L over D allowable, the modification factor times 8, I get 72.802, LLD actual to 3.77, so my actual is lesser than allowable, so pass. Red check, I get 70 millimeter, AF 374.24. The table give me 100 millimeter, so 70 is lesser than 100, pass. Then for detailing, this 3H16 at support, and then 3H10 at the footment, 3H12 200C center in this. For the BQ, first I find the concrete, I get 11.694 times the width times height, get 1.608 of meter squared of meter cube of concrete. Then I find the reinforcement. For top, I get 24.4 meter. For bottom, I get 2.4 meter of the reinforcement of steel. Then I find stirrup, I get 86.8 meter. Then for formwork, I get 6.706 for inner side, outer side, 6.4317 for inner side, so feet 2.9235 for feet. Then I calculate, and then I get 160.2.34. Thank you.